Hi guys, this is the Vijay, and today I am going you tell a very interesting topic, solid design pattern. And this design pattern, this is the guidelines to design any system and object-oriented systems. Uh, in this design patterns, there are the five principle, which I tell you about more, and why we are using these design patterns and what benefit we are getting. If we use design patterns, then our application is the robust, and it is the we can extend the functionalities, and it easy to maintain. Yeah. And then there is the first principle of the solid is the single responsibility principle. In this principle it says we there are the so many concerns that we need to separate to each other. Let's take one example. There is the employee service. There we are getting the employee, we are saving the employee, and if this is the ordinary design, then we include the functionality of sending the email. But this is the not a good design. Why? Because in IT industry, every time new requirement came, if client said, okay, I want email in the HTML format and in PDF format, then what we will do in ordinary design, we will write two extra methods like HTML and PDF. Yeah, but if we follow the good and right approach, then what we will do, we will separate both concern, employee concern in the employee service, and email concern in email service. Then if new requirement come to the email, then we don't need to made any modification into employee service. The goal of this principle to, if we did any changes in one concern, then other should not be affect. Yeah. Then what is the good way to achieve single responsibility? A single responsibility we also achieve at the method level. At that method level, what is the means of method level? Sometimes method are also taking too much responsibility. The good way to achieve single responsibility: extract the method where you find large methods, and if you are extracting method over and over, and last you will find, okay, now this method can't be extract. It's mean that method is handling single responsibility. If method is handling multiple responsibility, definitely it is the sign that method is the large and big and amount. Yeah, and then it's very best thing to extract method, and we can achieve single responsibility at the method level. Now, okay, let's talk about the second principle. This is the open close principle. And what this principle said, we don't need to modify. This is the close for modification and open for extension. Like if some feature come, then we have to create some subclasses, and we have to provide that features. Like there is the one a report thing is there. Previously client was only HTML report, now client want PDF report also. Then in this case, if ordinary design, then what we will do, in one report we will write so many code for HTML and PDF report. But according to solid principle, what should we do? We have to create one interface, a report interface, and we have to create subclass, HTML subclass, HTML report subclass, and the PDF subclass, and we have to define their functionality there. and by that if we are other like if client wants XML report then what we will do, we will create other subclass and we will extend the functionality for the reporting. By this rule, this principle, we get maintainability in our system. That's why it's very good. By extra creating new introducing the base classes, we can achieve this rule. Third rule is the Lisco substitute principle, and this principle said subclasses are always supportable for compatible with um, our base class. What is the concept behind this? Let's one example. There is the car and there is the some engine and the accelerator. Nowadays the this era is the 2019 and there is the one person is the Elon Musk and he it's introduced electric cars, and electric cars there is the no engine, then what we will do? Yeah, then we realize that okay, our design is not as per expected and it's not good, and we violated the third rule, and now our electric car is not supporting to our base class, because if we implemented this, then definitely somewhere we will get some errors and will it will not behave like expected. Then we have to refactor our interfaces, our design, and we can go further. And let's talk about fourth principle. This is the interface segregation principle. This principle says you should split interfaces based on their functionalities. Let's take example. We are going to suppose developing a system for IT firms, where some leads are there, which are dividing huge tasks into small tasks, and they are creating subtasks, and they are assigning to their team members, and they are working on itself. If we are use the ordinary design, then we will write three methods in the single one, like create method, create subtask, assign task, and work on the task. But let's take one example. New role came manager, and managers dividing the task and assigning to someone, but some other person are not assigning task to manager. Then if we extend that we implement our ordinary interface, then manager class has to define the work on task. Then this is the node, because manager are not is for working on the task. Then this approach is not good. Then we have to follow fourth rule. We have to segregate responsibility as the form of interfaces. Now what we will do, previously interfaces we split into two parts. One is the programmer, which working on the some task, and we will split another interface, that is the lead, and the leads creating subtasks and assigning to one. Now if programmer is there, then it's thing programmer will extend work on a programmer interface, and employee will extend programmer interface, and they work on the task. What is the case of team lead? Yeah, team lead, they will extend lead interface, because lead interface, and they will extend programmer interface also, because sometimes they have to work on also. They then lead creates subtasks, they are assigning and they are working on that. And if manager is there, and in this case, what manager will do? Manager will extend lead interface, implement a lead interface, and they will only create subtask. Yeah, see, with the this design principle, how much design is the very easy, and how we handle complex things in real scenarios. Yeah, and there is the fifth principle, and this that principle is the dependency inversion principle. And this principle said we have to maintain loose coupling in our system. High level classes, we have to depend on high level classes, not the low level classes. There what one a good example like a report. If there is the ordinary design, then we will pass a HTML report and we will get a HTML report. But this is the not a good design. If in future we can have a PDF report, XML report, Excel report, then what will the good design? Uh, we have a pass report interface, and in report interface we can pass any HTML report, PDF report, and PDF and any subclass object we can pass. Then we achieve the loose coupling in our system. Then these are the solid principle, and this change completely provide systematic system to us. Thanks for watching. Yeah.